In this video, we are going to learn to determine order of reaction. Before we proceed, we revise the term rate law. Rate law is an equation that relates the rate of reaction to the concentrations of the reactants raised to some power. So we have rate equal concentration of the reactant raised to some powers. For example, we have equation A plus B produce C plus D, where the rate is directly proportional to the concentration of reactant. If we want to write the rate law, we will write rate equal K concentration A to the power of X concentration B to the power of Y. If we talk about reaction order, based on the rate law, the reaction order is X with respect to A and reaction order is Y with respect to B. The overall reaction order is X plus Y, while the term K is called rate constant. The exponents X and Y can be integers, fraction, decimal, or negative values. Please remember here that the value of X and the value of Y is not the same as the coefficients in the equation. There are 4 methods to determine order of reaction. The first one is the initial rate equation method. The second one is the unit of rate constants. The third one is the half-life based on the graph against time. And the last one is the linear graph method. In this video, we are going to focus on the initial rate equation method and the unit of the rate constants. The first method, initial rate equation method, is used when the data is reaction rate at several initial concentrations of reactant. Maksudnya, metod yang pertama ni kita boleh guna sekiranya kita diberikan data untuk beberapa eksperimen. For example, in this question, the initial rates for the reaction A plus B produce products are given in the table below. Kita diberikan satu table yang mengandungi beberapa data eksperimen. Untuk soalan macam ni, kita boleh gunakan first method. To solve these questions, we have to compare two experiments in which the concentration of one reactant varies and the concentration of the other reactant remains constant. Kita akan pilih dua eksperimen di mana concentration of satu reactant tu sama dan satu lagi concentration adalah tak sama. Sebagai contoh, kita tengok eksperimen 3 dan eksperimen 4. Kalau kita compare dua-dua tu, kita boleh nampak concentration A berbeza tapi concentration B adalah sama untuk kedua-dua eksperimen. So, kita boleh ambil data eksperimen 3 bahagikan dengan data eksperimen 4. So, bahagian atas adalah data eksperimen 3, initial rate 18, kemudian K, concentration A 0.5, concentration B 3.0. Bawah eksperimen 4, initial rate 18, K, concentration A 1.0, concentration B 3.0. Kita boleh cancel K atas bawah, kemudian concentration B atas bawah boleh cancel. 18 bahagi 18 sama dengan 1, 0.5 bahagi 1 sama dengan 0.5 kuasa X. Kita selesaikan guna log, kita akan dapat X sama dengan 0. So, kita boleh tulis reaction is zero order with respect to A. Untuk dapatkan value of Y pula, kita boleh compare eksperimen 1 dengan eksperimen 2. Kalau tengok dalam table, concentration A adalah sama untuk kedua-dua eksperimen, tapi concentration B adalah berbeza. So kita ambil data eksperimen 1 bahagi data eksperimen 2. Kita buat sama macam tadi. Sekarang kita boleh cancelkan K. Kita juga boleh cancelkan concentration of A. So 2 bahagi 8 sama dengan 1/4. 1 bahagi 2 sama dengan 1/2 kuasa Y. Menggunakan log, kita kena selesaikan dan kita akan dapat Y equal to 2. So, direction is second order with respect to B. Untuk kira overall order of reaction, kita akan tambahkan X dengan Y. So, X tambah Y, 0 tambah 2 sama dengan 2. Okey, soalan seterusnya dia minta kita tuliskan rate law. So, kita akan tulis rate equal to K, concentration A kuasa 0, concentration B kuasa 2. So, kalau dia kuasa 0, kita boleh cancel terus. So, jawapan akhir dia akan jadi rate equal to K, concentration B kuasa 2. Untuk soalan C, kita nak cari nilai K. So, kita boleh gunakan mana-mana data eksperimen. For example, dalam soalan ni, kita gunakan data daripada eksperimen 1. Kita masukkan nilai rate sama dengan 2, concentration B 1.0, kemudian dia ada kuasa 2. Kita selesaikan, kita akan dapat nilai K 2 dm³ per mol per second. Next example, kita ada oxygen plus 2NO produce 2NO2. Kita nak cari rate law dia untuk reaction ni. So, kita ada eksperimen, several data. So, kita kena gunakan initial rate equation method. So, the rate equation is rate equal to K, concentration O2 kuasa M, concentration NO kuasa N. To find the order with respect to O2, we find and compare experiments that has concentration NO constant but concentration of O2 varies, which are experiment 1 and experiment 2. So by dividing data from experiment 2 with data from experiment 1, we can get 2 equal to 2 to the power of M. By using log, we can find the value of M is 1. So the reaction is first order with respect to O2. We do the similar calculation to find the order with respect to NO. So by comparing experiment 3 and experiment 1, where the concentration of O2 is constant but the concentration of NO is double, we can find the value of N. So by dividing the data from experiment 3 with data from experiment 1, we will get 4 equal to 2 to the power of N. By using log, we can get N equal to 2. So the reaction is second order with respect to NO. So we can write the rate law is rate equal to K, concentration O2, concentration NO2 to the power of 2. The second method is by looking at the units of rate constant K. For example, if we have a reaction A produce B, the rate is equal to K concentration A to the power of X. If X is 0 order, so the rate is equal to K, which means the unit of K is the unit of rate. So, if the unit of rate is molar per second, so the unit of K for 0 order is molar per second. The unit for per second can also be in per minute, per hour, per day, or any unit of time. If X is first order, the rate equal to K concentration A to the power of 1. The unit of K would be m per second divided with m, and we will get per second. It can also be any per unit of time. Last but not least, if X is second order, rate is equal to K concentration A to the power of 2. So the unit of K would be m per second divided by m to the power of 2, and we will get per molar per second. For example, the above reaction is first order with respect to iodide ions and to thiosulfate ions. A. Write the rate equation for the reaction, and B. What is the unit of rate constant K? If we look at the question, it says that the order of reaction with respect to iodide ions is first order, and with respect to thiosulfate ions is also first order. So we can write the rate law as rate equal to K concentration of thiosulfate to the power of 1 concentration of iodide to the power of 1. B. To find the unit of rate constant, we can divide the unit of rate, which is m per second, divided by the unit of concentration for thiosulfate ions and iodide ions. Hence, we can get per molar per second.